Welcome. I'm delighted to join you. I'm Julie Van Stappen, Chief of Resource Management, and have had the privilege of spending over 30 years in the stewardship of the Apostle Islands National Lakeshore. Over the next 2 days, presenters will share their wealth of knowledge and experience to weave together the rich story of the Apostle Islands. My goal for this presentation is to provide an overview of the history of natural resource management and research at the lakeshore over the past 5 decades, highlighting changing issues and needs, the collaborative relationship between the park, researchers, and partners, how technology has transformed our ability to keep a pulse on the resource, and to touch on a few stories that aren't being told by other presenters. And equally as important, to say thank you to all those who have worked tirelessly and passionately to learn, understand, and uncover the secrets of this amazing place. First, some background. What's so important? What's so special about a bunch of islands anyway? Apostle Islands are a homeland, a place of adventure, solace, and beauty, a fascinating natural laboratory, habitat for diverse plant and animal communities, a refuge for those that are rare, and a place of national significance. Spread out in a matrix of Lake Superior the size of Rocky Mountain National Park and influenced by the maritime climate the lake creates, the park includes 21 of 22 islands within the Apostle Islands archipelago and a coastal mainland unit, with 80% of the park designated wilderness. The aerial images on this slide illustrates just how large Lake Superior is and shows the location of Apostle Islands. Access by boat across cold, unpredictable Lake Superior creates daily challenges. However, challenges are often opportunities. Isolation and buffering from Lake Superior has protected the islands from many of the impacts other parks face. This unique collection of islands has a rich, intertwined natural and cultural history. Each island has its own story, yet is tied to one another and to the greater region that has shaped it. From the park's recovering forests and rare growth remnants, shown are ones from Outer and Raspberry Island, to its sandscapes, three of my favorites are shown on this slide, including Outer, Long, and Julian Bay, and wetlands that are some of the highest quality in the Great Lakes. The Stockton Julian Bay Lagoon and a rare carnivorous sundew are shown on this slide. To its stunning maritime cliffs that provide important habitat for Arctic plants. Seen on this slide are views of sandstone cliffs on Devils and Eagle Islands, as well as Arctic primrose, shown in the lower right-hand side. The park has a wealth of cultural resources, including what's considered the finest collection of historic light stations. Examples shown include an aerial view of the Old Michigan Lighthouse and Outer and Devils light stations. Culture Resource Manager Dave Cooper will be presenting next on 50 years of cultural resource research at the park. The park also has historically significant cultural landscapes. Examples include a cabin that is part of the Rocky Island Historic District, shown in the lower left-hand corner of the slide, the historic Manitou Fish Camp in the upper left-hand corner, and the West Bay Club on Sand Island in the upper right-hand corner. And archaeology dating back thousands of years. An artifact is shown in the upper left corner, archaeological fieldwork in the upper right side, and part of a shipwreck in the lower right side. In the past 150 years, the park's landscape has undergone dramatic changes. Natural processes such as fire and wind have affected the park's ecological landscape over time, as have human activities such as the use of fire, fishing, hunting, trapping, farming, quarrying, and logging. Of these, commercial logging had by far the greatest impact. Not only were great quantities of trees removed and forest composition changed, but in some locations, severe slash fires followed the cut. The majority of commercial logging occurred between the 1880s and 1920s, although some logging continued into the early 1970s. A picture of historic logging can be seen in the slide's upper right-hand side. Prior to commercial logging, 90% of the Apostle Islands were covered with northern hemlock hardwood forest, dominated by hemlock, white pine, sugar maple, yellow birch, and white birch. As a result of commercial logging, the abundance of hemlock and white pine was greatly reduced, and forest dominance shifted to sugar maple and red maple, as well as pioneering species such as white birch, balsam fir, and aspen. Following these habitat changes, deer numbers increased on some islands while staying in low numbers on others. In the 1950s, researcher Ed Beals from University of Wisconsin studied the influence of deer on island vegetation. And state biologist Bert Dahlberg, shown in the lower left-hand side of the slide, sounded the alarm after visiting Rocky Island, noting the fastest buildup of deer population and the fastest degeneration of habitat he had ever seen. The forest had rapidly changed from one with a ground cover dominated by Canada yew to near extirpation of this rare plant. Hunting in the 1950s to mid-1960s, along with overbrowsed, deteriorated habitat, severe winters and starvation resulted in large reductions of deer on the islands. A photo showing the results of a deer hunt on Rocky Island is seen in the slide's upper left side. So there you have it, a very brief overview. Now let's get going. The last exciting 50 years can be divided into 4 significant time periods, beginning with 1970 to the mid-1980s. The story starts on September 26, 1970, after tireless efforts by Senator Gaylord Nelson and many others resulted in the establishment of Apostle Islands National Lakeshore to conserve and develop for the benefit, inspiration, education, recreational use, and enjoyment of the public certain significant islands and shoreline of the United States and the related geographic, scenic, and scientific values. A photo of Gaylord Nelson can be seen in the slide's upper right side and a scenic pic from Stockton on the left. 16 years later, in 1986, Long Island was added to the park. One of the highest quality barrier spits in the Great Lakes and habitat for endangered piping plover can be seen in this aerial photo. Tasks for early park managers are many, including staffing, planning, land acquisition, and collecting baseline information on all aspects of the park. The first natural resource professional, Bob Brander, seen next to a very large stump left over from the logging days, was hired as a park ecologist in the mid-1970s. Bob played a key role in establishing a solid research and science base for the park planning and resource management. Bob encouraged scientific interest and developed partnerships with academic, federal, state, and tribal staff. He also began an Apostle Islands annual research conference in the mid-1970s, which continued for many years and was a favorite event, bringing together researchers, resource managers, and the public to exchange ideas and encourage collaboration. Comprehensive ecological inventories completed during the 1970s and early 1980s were critical in providing information needed to thoughtfully plan visitor amenities, including campsites and trails. Inventories were completed on 10 islands by Northland and University of Wisconsin Stevens Point. Researchers in the field can be seen in the 2 pictures on the slide. Colonial birds have long been used as ecological indicators. They feed high on the aquatic food chain and can pass along accumulated contaminants to predators, as well as being sensitive to disturbance. Early surveys conducted in the mid-1970s identified important nesting habitat in the islands, including colonial bird islands of gull and eagle. As a result, these islands are closed during the breeding season to protect nesting. Sumner Madison, Wisconsin DNR, seen in the center part of the slide, was part of the first survey and has continued to survey colonial birds in the park and along Wisconsin's Lake Superior coast every 5 years. 45 plus years and 10 surveys later, this is the longest monitoring program in the park and has tracked the ebb and flow of herring gulls, double-crested cormorants, and great blue herons. A photo of a gull chick and eggs can be seen in the upper left-hand corner of the slide, and surveys on Gull Island in the upper right and lower left corners. Bald eagles, a top predator in aquatic systems, are an important biosentinel in aquatic systems. Eagle research in the park began in the mid-1980s with Karen Cozy's work on food habits, foraging areas, and chemical contaminants. A high percentage of herring gulls were found in the diet of nestlings, likely contributing to contaminant loading. In the early 1990s, productivity still lagged behind nest sites away from islands and Lake Superior coast. Extensive research on contaminant concentrations and eagle reproduction in the early 1990s concluded that depressed eagle productivity was due mostly to naturally low food supply, rather than contaminants in the food web. Work was conducted by researchers Mike Meyer, Cheryl Dykstra, and Keith Warnke. More recently, Bill Rowdy of the Park Service's Great Lakes Inventory and Monitoring Network worked with others from 2006 to 2015 to determine contaminant trends. The good news is that the overall trends in contaminants has been downward and eagle nesting upward. By 2018, there were 46 nesting pairs on 20 of the park's 22 islands, a true success story. Looking from left to right, Eagle researchers Karen Cozy, Mike Meyer, and Bill Rowdy in an eagle nestling are shown in this slide. Baseline information was also needed on park visitors, as the new park anticipated the need for visitor services. Research on boater behavior began in the mid-1970s and was repeated in 1985 and 1997. This long-term longitudinal study found that over time, a high percentage of boaters were older, more tolerant of crowding, more skilled, and more committed to boating in the Apostle Islands. The research was led by Tom Heberlein and Walt Kuntzel. For those too young to remember, imagine doing research in the park without a GPS, only a map and compass to guide your way. Having to keep track of time as you operate a boat in the fog with only a map, compass, and rudimentary radar. No cell phones or internet, and the lake still as rough and unpredictable, and the islands just as challenging to traverse. And now it's time for time period 2, mid-1980s to 2000. In the mid-1980s, a second natural resource position was provided to the park, complements of the Park Service Resource Management Initiative. Filled for a brief period of time by Janice Meldrum, then much longer by myself, Jeff Smith, and currently by Peggy Bertman. All but Janice Meldrum are shown on the slide. The addition of this position enhanced the park's ability to address short-term needs and threats and develop a long-term monitoring program that serves as an early warning system for key resources and ecological indicators. Monitoring projects highlighted on this slide include amphibian monitoring in the upper left side, sandscape monitoring in the center left, campsite monitoring in the lower left, exotic species control, a purple loosestrife in the upper right, and breeding birds in the center right. Monitoring projects range from air and water quality to vegetation, amphibians, breeding and migratory birds, mammals, and campsites. Many of the original projects continue, providing a data set spanning over 30 years. To assist with managing all of the data created by these projects, volunteer extraordinaire Mike Kutnick, with assistance from Kim Pemble, seen in the lower right-hand corner, came to our rescue, developing a resource management database whose updated version is still in use today. Important data gaps were filled by researchers, including a synthesis of the geology of the park. A guidebook to the geology of Lake Superior's Apostle Islands National Lakeshore by Ed Newfer was published in 1987. Images of the park's sandstone cliffs, sandscapes, till bluffs, and a geologic map can be seen from left to right in this slide. Baseline water resource data was collected by the U.S. Geological Survey between 1979 and 84. Surveys included the park's streams, lagoons, Lake Superior, and groundwater, providing important baseline information. In the mid-1990s, water quality surveys were conducted, long-term monitoring sites established, and protocols developed, providing guidance used by park staff to conduct annual monitoring of lagoons and nearshore sites. Photos in this slide show water quality monitoring in Lake Superior and the Outer Island Lagoon. Flora of the Apostle Islands was published by Emma Ujewicz and Randy Koch in 1993, providing a comprehensive summary of the park's flora. This remains one of the most valuable sources of natural resource information. For this project, Emmett, seen in the upper left-hand corner, collected data on thousands of plots, bushwhacking across every island with only the aid of a map and compass. Also on the slide is a picture of Arctic primrose and old-growth forest. Park-wide soil surveys and vegetation maps were completed by the Natural Resource Conservation Service and University of Wisconsin, providing the park with important baseline information needed for planning. A map of soil types can be seen on the left and a vegetation map on the right. Baseline surveys were also conducted for lichen by Cliff Wetmore, which are used as indicators of air quality, lepidopterans by Les Fergie, and amphibians and reptiles by Gary Casper. Gary, shown in the lower left-hand corner, will be presenting on amphibians tomorrow morning. Also shown in the slide is a spotted salamander, swallowtail butterflies, and lichen. Research on the park's coastal inland wetlands was conducted by Jim Meeker and Northland students beginning in the mid-1990s and extending to 2010. The research focused on understanding successional dynamics over time with changing lake levels. This work provided important baseline information the speaker, Sarah Johnson, will expand on tomorrow afternoon. A photo of Jim Meeker can be seen in the upper left-hand corner, a park wetland in the lower left-hand corner, and Jim, Joan Elias, and Sarah Johnson in the upper right-hand corner doing plot measurements. And research began on black bears. In addition to being an important part of the park's wildlife, bears are the most likely to excite visitors in less than positive ways, increasing the importance of understanding their population and behavior. Between 1984 and 1995, bear research was conducted by Ray Anderson from University of Wisconsin-Stevens Point and grad students Jack Massapus, Dave Traba, and Karen Fleming, using live traps and radio collars. The island population on Stockton increased from an estimate of less than 4 bears in 1984 to more than 31 in 1994, one of the highest densities recorded in the United States. At high densities, bears exhibited cannibalism and overlap of home ranges, behaviors that appear to self-regulate the population. Grad student Jack Massapus and Dr. Ray Anderson can be seen in the lower left-hand corner and an island black bear in the upper left-hand corner of the slide. In 2001, researchers began to use non-invasive DNA analysis of hair samples to determine population dynamics of black bears. This work has provided a wealth of information. Research conducted by Jerry Blount and Dave Packo was conducted in 2001 and again in 2009. They discovered unique genetic signatures of bears on Stockton, Oak, and the mainland/sand and documented a dramatic change in the Stockton bear population. This population declined from an estimated 26 in 2001, which is very similar to the 96 estimate, to 13 in 2009. A third and expanded round of genetic-based research began in 2020. It will be exciting to find out what current researchers Monica Cooper and John Pauly from University of Wisconsin discover. Jerry Blount and grad student can be seen installing a bear hair snare in the upper right-hand corner of the slides, and bears brushing a hair snare can be seen in the lower right-hand corner. You've made it halfway, moving on to time period number 3, 2000 to 2010. In 1999, the Park Service's Natural Resource Challenge began. With the goal of acquiring information needed to protect park resources into the future, it created, among other things, Park Service-wide natural resource networks or teams that would serve groupings of parks sharing information and expertise. Apostle Islands National Lakeshore is included in the following: the Great Lakes Inventory and Monitoring Network, which conducts inventories and long-term monitoring of park vital signs. A map of the parks included in the Great Lakes Network is seen in the slide. The Great Lakes Invasive Plant Management Team provides invasive plant management assistance. The Great Lakes Research and Education Center provides assistance with research coordination and public outreach. And the Great Lakes Northern Forest Cooperative Education Study facilitates research through its large network of universities. Beginning around 2000, the park experienced an eruption of deer on Sand and York Islands. Following the decline of deer in the 1970s, the deer population had remained fairly low until the 2000s when aerial surveys detected overwintering deer on Sand and then York Islands, two islands without a history of deer and with landscape scale Canada U. So why should this matter? Apostle Islands are a refuge for Canada U and forests that once were far more abundant. Canada U has been functionally extirpated on the mainland, largely due to excessive deer browse. And Rocky Island is our reminder of how quickly island deer numbers can increase, you disappear, and how long it takes you to recover. Browse and pellet service began, as seen in the upper left-hand corner, and the park started working on a harvestable wildlife plan with state and tribal biologists. Based on survey results that indicated a rapidly increasing deer herd and severe overbrowsing, the park's plan began to be implemented. The plan called for aggressive management control, especially on islands without a history of deer populations. The task proved harder than expected, as state-regulated, tribal, and volunteer hunters could not keep up with the growing herd. Success came when we were able to enlist the help of wildlife services, who greatly reduced deer numbers on both islands, donating all culled deer to tribal partners. This was no small effort, and success was largely due to the hard work, patience, and persistence of Dave Rood and others, as seen in the lower left-hand corner. Pics of healthy Canada U and heavily browsed U can be seen in the center of the slide. At the same time, From 2010 to 2012, Travis Bartnick, seen in the upper right-hand corner, and Tim Van Deelen from University of Wisconsin conducted a population study on Sand Island using remotely activated cameras and a mark recapture technique to estimate the deer population. This technique was successful in documenting the effectiveness of culling activities. Remote cameras continue to be used to monitor deer occurrence in the park. Threats to the park vegetation also came from gypsy moths, exotic invasive insects that have been responsible for large-scale defoliation in eastern forests. In the late 1990s, Apostle Islands was at the western edge of the country's gypsy moth invasion. Monitoring was conducted throughout the park from 1997 to 2008, documenting an increasing gypsy moth population that peaked in 2005 before declining. Subsequent research identified a decrease in defoliation and overall improved forest health by 2014. Although we dodged a bullet with gypsy moths, we need to stay vigilant as other insect pests like emerald ash borer and hemlock woolly adelgid move closer. A gypsy moth caterpillar setting out a gypsy moth trap assembly, and a log covered in gypsy moth caterpillars are shown in this slide. The impact of human traffic on many of our sandscapes was causing bare areas and erosion. Beginning in 2001, the park began to address this resource damage with the assistance of the Natural Resource Conservation Service. Park sandscapes are among the highest quality remaining in the Great Lakes and extremely popular visitor use areas. They also present a management challenge since sandscape vegetation is very sensitive to foot traffic. A combination of native plants propagated from plant materials gathered within the park, along with floating boardwalks and plentiful volunteer help, has proven very successful in protecting sensitive dune plants, as well as making it easier for visitors to experience these special places. Shown in the slide from left to right are Sarah Johnson and her class seen on a floating boardwalk, students waiting from the boat with hands full of plant trays, and planting on Stockton Island, Quarry Bay. An exciting highlight during this time was the return of federally endangered piping plover nesting on Long Island. This occurred in 1998 after a 15-year hiatus. Plover protection and management from the beginning has been a successful collaboration with the Bad River Tribe, Wisconsin DNR, Fish and Wildlife Service, university partners, and the Nature Conservancy. Stay tuned for Sumner Madison's presentation on piping plover recovery tomorrow morning. Going clockwise and beginning in the lower left-hand corner, pics show plover banding, a plover banding crew, a chick with a new band on its leg, a sign informing the public of plover nesting area, and an adult plover. Technological advances in acoustic monitoring in bat and calling amphibians have greatly increased our ability to monitor these wildlife populations. A frog monitor installed near the Stockton Lagoon can be seen on the left-hand side, and a bat monitor is in the process of being installed on the right-hand side. And we've come to our most recent time period, 2010 to 2020. The 2010s brought many challenges, especially climate-related, including more frequent and intense storms, as well as a rapidly warming Lake Superior. To help the park plan and prepare for predicted changes, the Park Service's Climate Change Program facilitated climate change scenario planning and a climate change vulnerability assessment. The vulnerability assessment was led by Steve Handler from the Northern Applied Institute of Climate Science. Stay tuned for Steve and Peggy Berkman's presentation tomorrow afternoon. This slide shows storm damage to sandy bluffs on Stockton Island and the storm that destroyed the historic Hokanson Dock at Little Sand Bay. Brendan Marasco-LaFrancois will present this afternoon on how these changes are impacting water quality, including unprecedented algae blooms and the discovery of exotic Dreissena mussels. An image of algae bloom at Myers Beach and invasive Dreissena mussels are shown on this slide. The Great Lakes Restoration Initiative, established in 2010, has greatly increased the park's ability to tackle many of these issues, including protection and restoration of rare coastal communities, both maritime and sandscapes, increasing the park's ability to conduct early detection, early control of invasive species, increasing success, and to provide important outreach to the public. Nearshore monitoring and studies to determine the distribution, pathways, and control of exotic Dreissena mussels. Interdisciplinary and comprehensive wetland surveys, Make sure to take in Matt Cooper and Sarah Johnson's presentation tomorrow afternoon. Also, fire history and the reintroduction of fire as a cultural practice and restoration tool. Don't miss presentations by Damon Ponick and Kirk Kiffmuller, who will be presenting this afternoon. And protection of state endangered American marten. Starting in the lower left-hand corner and going clockwise, this slide shows an American marten on Stockton Island, lush Canada yew in a maritime forest, Matt Cooper and students conducting wetland surveys, exotic purple loosestrife, and the Stockton Island cultural burn. The park faced increased safety concerns as the mainland sea caves became increasingly popular and fatal kayak tragedies occurred. To try to prevent future tragedies, coastal engineers Chin Wu and Josh Anderson and Gene Clark developed a creative response by developing the Apostle Islands real-time wave observation system. This system enables kayakers to check actual sea conditions before launching from Myers Beach. Since the system was installed, no fatalities near the sea caves have occurred. Sea Cave Watch developers can be seen in the upper left-hand side, along with Park Ranger Carl Carlson. A screenshot can be seen in the lower left-hand corner and a schematic of the system in the upper right-hand side. Beginning with deer research that utilized remote cameras in 2010 and greatly expanded starting in 2014, there's been a blossoming of wildlife research. Thanks to remote camera technology and collaborative projects with the University of Wisconsin and Northland College. Remote cameras have transformed the ability of researchers and park staff to monitor the occurrence and distribution of wildlife, especially cryptic carnivore species. Cameras can monitor wildlife year-round, non-invasively and efficiently. Tomorrow morning, Morgan Farmer will present on this collaborative carnivore camera project. Matt Smith will be presenting on American marten recolonization, and Eric Olson on small mammal research. A remote camera setup can be seen in the slide's upper left side. The rest of the slide includes remote camera pics of sandhill cranes, deer, bobcat, and coyote. Other important projects include a comprehensive sandscape survey. The park regularly conducts sandscape monitoring to determine their status and health. The work done by Sarah Johnson and her students provided a much more in-depth analysis and strategies for improving long-term monitoring. Sarah also led comprehensive rare plant surveys, comparing data over time with a special look at climate change vulnerability, and worked with John Martin to determine effects of low-level fires on Canada yew. Pictures shown in the slide going left to right include the Outer Island sandspit, the rare plant team, butterwort, a rare Arctic remnant, and Sarah Johnson, monitoring a rare plant population. Take a deep breath. You've made it through our rapid trip over 50 years. In closing, as we review the last half century, we can document, celebrate, or lament the many challenges and successes. With such a diverse, collaborative collection of scientists, citizens, and knowledge keepers, we're excited about the future. Technological changes have been immense, transforming the tools available to resource managers and researchers and the manner in which we can measure, observe, and better understand this unique ecosystem we call the apostles. Emerging changes in our climate will require attention, vigilance, and action. Stewardship that the park has and will continue to require all of us working together. Looking back into our history, understanding today, and looking forward into the future, what challenges do you think resource managers will face in 2070? The Apostle Islands will still be here, but how will time affect them? We won't be here, but what would our grandchildren see when they look out across this jewel of ours? How can we learn from the past and present? Setting a course will improve our understanding and protection of these awesome, interconnected resources. What new discoveries will these islands reveal to us? What kind of new technology might be available to better assist us in understanding? What new challenges may affect the future, what we do, and how we do it? As you contemplate these questions, let me leave you with a glimpse of some of the many that have contributed to the park's research, resource management, and stewardship. Thank you, and I really hope you enjoy the symposium.